Okay, hello everyone and welcome to my class. Today we will be, this is our third radical class. Hold on, let me share my screen first. Okay, sharing my screen. Can you all see my screen or not? If you cannot see my screen, well then too bad. Okay, yes, you can see my screen. That's also very nice. Okay, so, no, you can't see my screen. That's even more sad. Okay, you can see my screen. That's nice. Hold on. Okay. Let's go to the slides. That's this much. Okay, so this will be 8th grade mathematics already. Yes, I'm moving very fast. So, we'll now learn about, actually, let's start with the review, our schedule today. First, we're going to have a review, square root functions, and then problems. Okay, so, and can't get enough problems, I know. So, let's start with our review. Can anybody tell me what the Pythagorean theorem is? Because that's what we need to do. Yes, it's very boring, I know, but that's my job, isn't it? To make life boring. Okay. So no one knows what. Oh, okay. At least some people know. Okay. Uh, let's see here. What have you got? Well, Stephen, that's not the Pythagorean theorem. That's way more complicated. But that is, let's see, a times square root of bx minus h plus k. Okay, that's a square root function. Very nice. You already know that. That's very sad. Okay, so Stephen, that's a square root function, and the Pythagorean theorem is a squared plus b squared equals c squared. Yes. Yes. The a and b are legs. Yes, legs. Legs need pants. Okay, we're just not going to talk about that. So c equals a squared plus b squared. Yes, everybody is correct. How does anybody want to do competition mode today, where if you get a question correct, you get a point, and whoever gets the most points, okay, you win by the end? Does anybody want to do that? Actually, also, you have to put the answer incorrect first. Yeah. Okay. Wait, what? Please no. Yes. Okay. Yeah. Not very popular, huh? Okay. So Pythagorean theorem, the formula. Okay. The formula is a squared plus b squared equals c squared. Okay. That is the Pythagorean theorem. I can go in depth about all of this. It's very sad, actually. So basically, it applies to only right triangles. Okay, 90 degrees here, and then 45. Okay, no, not 55. 45. Okay, and then this will be A and B, which are the legs of the triangle, and the longest side is the hypotenuse, which is also C. Okay, so we're all clear about that. And I mean, who wants to go in depth about the Pythagorean theorem? Anyone? No? Okay, we're not going in depth about that. Actually, let's see. One comment. Okay, no competition. That's not even related. Okay, so actually, let's go in depth about more about the Pythagorean theorem, because I have nothing to do right now. Anyways, the Pythagorean theorem is very important in geometry. Okay, let's say you need this diagonal of what? The diagonal of this square or rectangle, you just need to multiply these two sides, okay, with a and b, and you just need to square root it. Very easy. And then also this is a two-dimensional diagonal, and then we also have something called a space diagonal, which we have a rectangle, or it's a cube, or whatever you want it to be. Okay, it's from this corner to the front corner, the back corner to the front corner. It's this diagonal. Okay, that's quite hard to find. No, not really. What you need to do is you need to draw a line over here. You see this this 2D triangle in the thing, okay, in the cube. Okay, basically just use what, okay, A, B, and C, okay, to find the space diagonal. Okay, a squared plus b squared. Okay, the square root of a squared plus b squared. Okay, that equals this line. And then if you get that line and c squared, which is this side, you can square root that and get this side, which is the space diagonal. And we can talk all about that and, you know, that kind of stuff. Okay, for example, if you have the surface area of a rectangular prism and the volume of a rectangular prism, and then you also have the space diagonal of it. Okay, you just need two of those, and then you can find the third. Okay, with some crazy formula. I think it's p over 4 squared equals something 2a plus d, or d squared. Okay, I can prove that later, but it's very important, okay? Pythagorean theorem, I think I've proved that already, but yeah. Okay, so now we are going to go to a completely unrelated subject of, did I just ramble on for like 3 straight minutes about, okay, this is high school geometry. Okay, simplifying radicals. Here we are again. So what are the 2 rules when simplifying radicals? Who knows them? Okay, 2 rules. Okay, who's gonna get first? I'm guessing it's Steven, if he didn't have a big head and forgot to take notes, or deliberately didn't take notes. It's very sad. Always take notes, kids, because you might forget something one day. Okay. Square root x, the square root of x is simplified. X must not be a factor of, x must not be a factor of, yes, not the exact clear definition I would like, but yes, that is true. Okay, first one. And then no square root in the denominator. Yes, that is correct also. So for example, 1 over the square root of x is not simplified. Yes, very good. So we have our 2 requirements over here, which is, okay, there are no perfect square factors in the radical. What is this handwriting? Okay, there are no perfect square factors in the radical. For example, is this simplified? We've gone through this in like already 3 classes. So if you don't know this, if everybody does not participate, then I'm gonna assume the ones that don't answer are quite stupid indeed. Or you're just, yeah, stupid and very, very, very. Okay, is this simplified? Let's see. So only Only 2 people are smart here. Oh, it's very sad. Actually, 3 people, including me. Yes. Oh, only Stephen and me. Oh, that's very sad. Not even Edward. I thought you were smart. No, no. Okay, 2 times the square root of 2. It is not simplified. Oh yeah, and Edward says not simplified. Okay. Yeah, you're not smart. No to smartness. Okay. Yep. Why are we talking about this? Okay, so why is it Desmos again? I need to move this around. What do you can't even move that around. Okay, so this is not simplified because it is what is 8? Okay, it's 2 times 4, and 4 is a perfect square. Okay, that's a perfect square factor, and you can't have that in the radical. And there are no radicals in the denominator. All right. No radicals in the denominator. Okay. And that is about it for the simplifying radicals. So radical equations, anyone? Radical equations. Okay, so radical equations are algebraic equations that have radicals in them, obviously. If they didn't, that would be quite sad. So, let's see. Radical equations. Let's start with some basic ones. Okay. So usually you have to what? You have to square both sides, or sometimes you need to isolate the radical. Usually square both sides or isolate the radical because you want to get rid of a radical. Okay. Because most radicals in here are not rational, they're irrational, and irrational numbers are hard to work with. Okay, so our first problem here is going to be square root of x plus 7 equals 16. Okay, can anybody solve that? That is quite an easy one. Okay, first you need to isolate the radical. So let's move the numerals here. Okay, the square root of x equals 9, right? 9, and then how do you need to get rid of the square root? The square both sides. So x equals 81. Okay, very easy. So well, I basically already showed you how to solve, but how to solve? Let's go for another one. Okay, so square root of 5t minus 11 equals square root of t plus 5. Okay, can anybody solve this? And I need more participation, guys. Are you just constipated, retarded, or dumb, or stupid, or idiotic? Which one are you? Or are you just quite intelligent and you just don't want to participate in this very boring review? Well, at least I hope you participate when we're learning new material. Yes. And that will be next class, because next class we are starting a new chapter. Okay. 5 comments. I hope this isn't Steven spamming the answer. That'd be quite sad. Let's see if it is. I'm putting my bet on Steven spamming the answer. Yes. Exactly. Well, apparently, it's Steven and Edward spamming the answer. Actually, okay, we're just naked. Yes, yeah. I'm glad you realized your mistake on your own. Yeah. Okay, so t equals 4. Yes, kids, t equals 4. In case you haven't noticed, it does equal 4. So what do you do here? Square both sides, right? 4t equals 16. And then if you think 16 divided by 4 equals 5. Okay, you can go back to 3rd grade. T equals 4. Okay, we're done. So now for our walkthrough. Actually, this isn't a walkthrough it's review problems. So, can anybody solve this equation? If you don't know, oh well. That's just sad. Yeah, that's very sad. We're talking about like 2 classes on this stuff and you still don't know. I think I'm a bad teacher, or you're just not paying attention, or AFK, or whatever that is. So this should be very quick solve. Okay, you can solve this however you want. Okay. Factoring, quadratic equation. Heck, you can even solve by graphing. That would be quite sad though. Yeah, don't graph that. No. Don't even try to graph that. That's very sad. Graphing is too slow. So, 4. Yeah, 4 comments. I'm putting my bets on 3 comments from Stephen, 1 comment from Edward. No, 2 comments from Edward then. Oh, wait. Actually, I think this is the time when Stephen actually got something incorrect. Okay, even if you switch it, Stephen, it's still incorrect. This Edward. Yes, don't remind me of my mistake last time, okay? -3 isn't 1, apparently. I don't know why it's not 1, but if an algebraic calculator says it's not, then it's not. Okay, so wow, we have more participation this time. We have Wombat, Maggie, Stephen, and Edward. And Stephen, are you punching yourself? Okay, Edward, if you think -3 squared doesn't equal 9, you can go back to 4th grade. Can you turn on your camera, please, Stephen? I'd like to see the very disturbing image of you punching yourself. No? No? Okay, fine. Thankfully, you forgot to bring... Oh yes, what an excuse. The square root of 9 equals -3, huh? I think you're so good. Actually, you are. Okay, so you think negative square root doesn't equal 9, huh? I'm gonna prove you wrong. Hold on. I need to get up Google first. Google is also a reliable source. Actually, it's a search engine. It's not reliable. So, what is -3 square root? Okay. The square root of -3. See, I'm gonna tell you, it's 9, kids. What the heck? What is this? CK. Don't show up some square root function in some trashy coding language. Also, I'm learning Python, not C. Okay, what is C? I know of C++. What the heck is C? Okay. Square root C++. Oh, wow. Okay. Okay, we're just not gonna talk about that. This is very sad. Huh? Square root 3 times I. Okay, let's just move on. I'm just gonna walk you through this one. Yeah, okay. So, basically, square both sides n squared minus n minus 12 factor. The factor, kids. Factor. When did it turn into x? Okay, so that aside, we factored, and then we're going to get 4 and negative 3. Okay, now let's check our solution. Negative 3 equals 9 square root of 9. Okay, that's not true. So 4 equals square root of 16. Yes, that is true. So 4. Why is there an infinity sign over here? Okay, let's just not talk about that. So simplifying this. Okay, who can simplify this? Okay, simplify this. Okay, give you a few moments. Just gonna. Yep. Bye. Okay, are you done already? This is very boring, you know. So no one knows the answer. That's very sad, you know. Extremely sad. Negative 52x to the 4th times square root 7x. Anybody else? So our answer is I don't know. Oh. Negative 52x times the square root of 7. Okay. Oh, you do know, huh? Well, if you do know, put your freaking answer in the chat. Yep, you do know. Yep. Well, if you do know, why don't you put your answer in the chat? Or are you afraid that it is wrong? Okay. First of all, based on my experience of simplifying radicals, I can tell that Maggie's answer is incorrect. And Steven's answer is probably correct. Okay. Maggie's answer is mostly correct. Okay. So now, let's start simplifying this. Okay, so square root of 28x to the 9th. Okay. It's made up of square root of 28 and square root of x to the 9th. Okay, so what is square root of x to the 9th? It is square root of x to the 8th and times square root of x. And what is square root of 8? It is x to the 4th, right? X to the 4th. And that is where you're wrong on, Maggie. Okay, you forgot to put to the 4th power. Okay. And then the square root of x. Okay. So in 28, we have what? Square roots of actually what's this? 28. Okay. We have actually 2 times the square root of 7 because it's 4 times 7. Okay, and the square root of 4 is 2. Okay, so we are done here. And then it'll just be negative 52x to the 4th times 7x. Okay, we're done here. Okay, And yes, your answer is correct. So now we will now go to square root functions. Yes, that is, yes, everybody is so excited for this. No, not really. No. Yep, I'm not excited either. So yes. So let's introduce ourselves to square root function. You always need a y in square root in functions, okay? And of course you need the square roots and then x. Okay, that is the parent function, okay? It's the most simplest form, okay? It's the simplest form. Okay. The simplest form, okay? So now let's draw a simple coordinate graph, okay? Okay, and let's just keep this positive, okay? We get problems, okay, when we're square rooting negative numbers. So it's usually let's not mess with negative numbers, okay? That would be very hectic. So let's draw a simple positive coordinate graph, okay, and let's see what a square root function looks like, okay? So let's have a table of x and y values. Let's have 0, okay? Because y, okay, because y, hold on, wait. Y equals the square root of x. So if x is 0, the square root of 0 is 0, okay? So if x is 1, the square root of 1 is 1. If the x is 4, the square root of the square root of x is 2. This goes on, 9 is 3, and what? 16 is 4. Yep. See here, we have 0, 0 here. 1, 1. 4, 2. And 5, 6, 7, 8, 9. Okay, right here. You see it leaps very far, okay? See, it's very slow descending vertically, but it grows very fast horizontally, and that is usually what a square root function is going to look like. You can go this way, you can go this way, okay, usually. And you can also increase the vertical growth. So parts of a square root function. So a square root function, usually, sometimes you don't have these values, but a full square root function is y equals a times square root of bx plus c plus d, okay? And let's think back to exponential functions, parabolas, okay? Usually these C and D values, or as you can call them, H and K, so let's see, vertex form and parabolas, okay, they what do they do? Okay, C, you add to the X value or subtract the X value, okay? It shifts horizontally. And D, usually it's a vertical shift. So now let's look at Desmos. Okay, where the heck is Desmos? It's gone? That's very sad. Let's go back to Desmos. Okay. So, hold on a second. Y equals, wait, with A, Y equals A times, okay, this is very sad. Times, where the heck is square root? Okay, times X. Actually, BX. 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 Okay. Actually, let's look at them one by one, alright? Let's look at them one by one, okay? So let's just add square root of x here, okay? See, this is the parent function, okay? It's the parent function, it goes on forever. It is the most basic, simplest function we can get with square root functions, okay? Let's add a, okay? Let's add a, okay? So what does a do? Okay, let's add a slider here. What does a do? Okay, let's animate this. What does a do? Okay. What does a do? Okay, does anybody know what a does? Let's observe this animation. What does a change in this function? What exactly does it change in this function? Okay, let's stop this animation. What does a change in this function? Okay, it changes shape. Yes, of course it changes shape. Of course it does that. Okay, what exactly? Okay, to be exact, it's a vertical stretch. Okay, the vertical stretch. It increases or decreases the amount of growth for the y. Okay, usually our parent function is like this. Okay, when it's positive, okay, the y increases. Okay, faster. Okay, let's say it's 10. Okay, it's 10. Then it will look like this. If it's 1, it'll look like this. All right, so let's write that down. A is a vertical stretch. Okay, so what does this mean? Okay, so when A is positive, as we see here, A is what? 8.47. Okay, that's positive. Okay, it's the Y is increasing positively. Okay, it's increasing. Okay, not decreasing. Okay, that doesn't make sense. Okay, it's increasing the Y value. So, and then when it's negative, which is less than 0, it will decrease the y value. Okay, here. So let's look at, is everybody taking notes? This is new material. This is very important. Okay. So let's look at B. Okay, what does B do? Okay, let's look at B. Okay, let's add a slider here. So what does B do? Any guesses on what B does? Okay, any guesses? No guesses. That's very sad. Okay, so B, what does it do? Okay. You see here, it's also a vertical stretch, but not as much as A, okay? Because it's basically multiplying, okay, the X. It's multiplying the X. So the Y will still increase, okay? But let's notice something different. Okay. B is also a vertical stretch. And then when B is greater than 0, which means it is positive, okay, it's facing this way, okay, just like when A is positive. Okay, but when B is negative, okay, it changes way, okay, it goes to the left now. The arrow points to the left, okay, that's what's special. Now C, you can finally, you can probably guess what it does, okay, and I've already told you, which is also very sad, okay. So add C. Okay, we don't need this. We're back in the square root. Let's not go out of it. Okay, so x plus c. Any guesses on what that does? What does c do? Okay, changes position. It shifts. And c changes the y-axis. Okay, those are semi-correct answers. Okay, it doesn't change it changes position, okay, but not size, okay. And Stephen, it doesn't change y coordinate. Edward got it right. It shifts x, okay. It's horizontal shift. All right. Hold on, what the heck is happening here? This is rigged. I'm gonna try adding A and B and all that good stuff. See if that works now. Actually, that still doesn't work. Okay. So now does it work? It still doesn't work. What is this piece of crap doing? How about we subtract C then? Okay, what the heck is this doing? No, not multiply C, okay. No, we're next button. Minus C. Okay. I see. Were they too far out? Oh, I see the problem here. I was too far out. Okay, that's dumb. Okay, let me go back here and now let's animate it and see it's moving. It's too far out. That's sad. Go back. Where did it go? Where the heck did it go? Oh, there it is. So now you see it's kind of moving. Okay, it's moving. Okay, so it's moving like that. It's a horizontal shift. Okay, so let's write that down. C is a horizontal shift. Okay. So C is horizontal shift. Okay, let's not do that. Okay, so actually you see here when C is positive, it actually goes to the left. It's kind of weird. Okay, not what we expect. But we've seen that a lot in functions. For example, exponential functions. That's also the case. Okay, when C is positive, it actually goes left to the negative side. Okay, when C is negative, okay, it goes to the right. So now let's look at D. Just add D on there. Okay, so if D equals 1, okay, you can see kind of this, what's it called? The origin or the vertex. Basically, the start of this function is the y value is D. Basically, if it goes positive, it's up. If D is negative, it goes down. Okay, D here, okay, and moves, shifts vertically. Okay, the vertical shift. Okay, so when D is positive, it goes up. D is negative, it goes down. Okay, so we're done here. Actually, let's see what it looks like. All of them are in action. Okay, what does it look like? What the heck is happening here? That is crazy. Very sad. What the heck? Oh, well. Well, any type of square root function is supposed to look like this, apparently. You get the idea. Let's see where we stop at. Oh, this one stops at that. Okay, so now let's look at how to find the domain in the range. Okay, so how do you find the domain in range? Because I'm going to ask that. I have nothing else to do. So, how to find, okay, let's choose an example. Y equals 2 times the square root of 3x minus 9. Okay, this is a function, okay, where 2 is A, 3 is B, and C is 9, negative 9 actually. So what is the domain? Okay, let's in the range. Let's review, okay? The domain is all possible x values, okay? And you usually don't denote that as what, a range of numbers, okay? So like 1 to 3, all the possible x values are in there. Okay, and then the range is all possible y values. So let's see. In this function, what we need to really care about is what's in this. Okay, what's in the square root. Okay, let's care about that. So the domain. Okay, you can't have something in this square root that is negative. All right. If you get a negative number in the square root, it's not going to work because you can't take the square root of a negative. Okay. So you need this to be greater than or equal to 0. So to find the domain, you basically need to find all x values are greater than or equal to what? Okay. 3x minus 9 needs to be greater than or equal to 0. Okay. So 3x is greater than or equal to 9, and x is greater than or equal to 3. Okay, so that's our domain. Basically, 3 to infinity. I have to bracket here, okay? That's a very bad bracket and an infinity sign, okay? We're just not going to talk about that. Okay, that is our domain and our range, okay? You usually don't need to write this if you don't want to. Basically, all you need to know is this, okay, and you'll be fine. So in the range, what you need to do, okay, has to be greater than or equal to 3, right? So y equals, just sub that in, okay, sub 3n minus 9, okay, and then y equals 2 times the square root of 0, and then y is greater than or equal to 0, okay, and it's usually like that. So that's how to find the domain and range. So now let's move on to problems. So what are the domain and the range of the function y equals 12 minus 4x? Can anybody tell me that? Okay. Okay, so any answers that we have? No answers? No? Do not know how to do it. Okay, Edward has an answer or just a comment or anything. Okay, x is smaller than or equal to 3 and y is greater than or equal to 0. That is correct. Okay, so let's walk you through this. And wow, Edward actually beat Steven this time. Great surprise, okay? So 12 minus 4x is greater than or equal to 0. Negative 4x is greater than or equal to negative 12. And what? X is smaller than or less than or equal to, because you're dividing by a negative here, you have to switch the sign. 3. Okay. And then y is usually just y is greater than or equal to 0, because if you really just plug this in, it's 0. So y is greater than or equal to 0. Okay, so that is our answer. And what is the answer to the second problem that I have for you? Okay, 2 comments, 3 comments. Okay. Oh, okay. Problem 1. Hopefully you can still write. My handwriting is very bad and I didn't explain that much. But I did explain. I just didn't write it down what I explained. So, and also whoever that said what domain is 13/8, you're correct. I think so. Okay, so x is greater than or equal to 13/8. And y is greater than or equal to 0. Basically, you don't even need to solve for the y, because it's always like y is greater than or equal to 0. So let's just find the domain here. Okay, so the domain ax minus 13 equals greater than or equal to 0. Okay, then just add 13 to this side. Okay, divide. That's the domain. Okay, and the y is just that. Okay, so we're done here, and that is the end of the problems that I have for you. So thank you for listening, everyone. Be sure to come next class, because we will have a next new topic next class. And thank you for listening, everyone. Well, not really. Most of you didn't listen, probably. Okay, Steven, we already did number problem 2, huh? Hey, Steven, after summer break, I'll do geometry, all right? We're doing algebra right now. It's kind of have a theme going on, right? Okay, Kai, see, you want to go back to problem 2? Oh, yes, and have a good day, Maggie. Problem 2, where the heck is problem 2? Okay, I need to stop sharing real quick. to find the files. It's not gonna let you see that. It's gonna be very sad. Okay, where's the file? Document right on PDF. Okay. Yep. This is problem 2, right? Problem 2. Okay. This is problem 2. Who needed problem 2 again? Who needed problem 2? Okay, Kai. He needed problem 2. Okay, this is problem 2. Okay, this is problem 2. Write what you need to write. Okay. Domain and range. Okay. And we're paying attention to the square roots here. Okay. Okay, so are you done yet? Okay. The next class topic. I don't know. I'm gonna have to look through my notebook. I'll catch up to you next class. Or next class might be in math counts. That's because school is about to end. Then math counts will be in the summer. Actually, I already passed, so never mind. What is AMC 10? AMC 10. Okay, I need to stop recording here.